Okay, this is part 3, and I recommend before you watch this tutorial, you watch part 1 and 2. Part 1 was to help you just understand the two air masses involved in the creation of the ITCZ. In this case, it was the tropical continental air mass and the tropical maritime air mass. And the ITCZ represents the point where they meet. The ITCZ is basically a weather front. And you'll remember learning about weather fronts when two air masses meet when you were doing National 5 geography. Part 2 of the question focused in on how you describe the variations in rain at different places in West Africa, especially in relative to the coast, and as you move further inland, how it becomes dry and how the rainfall throughout the year varies. Part 3, and that's what this tutorial will focus on, is what are the reasons for those variations? And that is actually to do with the movements of the ITCZ. But before we get to the movement of the ITCZ, we need to establish what the ITCZ is, and we would need to be writing about that in order to pick up some marks. So if I have a little look at some graphics here, the first point you want to make is that the ITCZ itself represents the point of low pressure, and you'd want to write that. So it's the point of low pressure where trade winds are moving towards this point, and it's where they meet. So the ITCZ is where the trade winds meet, and those trade winds are coming from an area of high pressure at the tropics, moving back towards the equatorial region or the equator. And they're coming not just from the Tropic of Cancer up here, but they're also coming from the Tropic of Capricorn, and they're meeting along this convergence point here, and that is the ITCZ. So mark 1 comes from telling me the ITCZ marks an area of low pressure where the trade winds meet. Okay. Now the second mark comes from that the ITCZ lies underneath the thermal equator. Then this is the zone on the planet of maximum heating. Okay. Now before we talk about the zone of maximum heating moving, the zone of maximum heating is simply, if I just do this little graphic here, it's the point where the sun is most directly overhead at that time of the year. Okay, so the intertropical convergence zone will lie directly underneath the zone of maximum heating, which is the thermal equator. Third mark comes from, because this is the area where there is the most heat on the planet, there will be the maximum amount of convection happening. Now, when I talk about convection, we're talking about, and you'd write a sentence, this is where air is rapidly rising. So air is being drawn in from the trade winds from both sides, reaching this point. It's very hot at this point, so the air automatically starts rising upwards, forming massive clouds, because this zone is lying at this point over an ocean. Therefore, there's huge amounts of evaporation. As the air moves up, it takes water vapor with it and forms huge clouds. Therefore, the area that lies directly underneath the zone of maximum heating is likely to be the wettest because of this high amount of convection. Now, you remember all of this is linked to the idea of the Hadley cells, with air rising and circulating around back on the surface to that point and then rising again. And that's happening north and south of the equator. So far we've got a lot of key points we will have written about before we've even talked about the movement of the zone of maximum heating. Okay, now the movement is to do with the changes in the Earth's axis relative to the sun. We're talking about the axis tilt. Now, because of the axis tilt varying throughout the year, in our summertime, when I say our, I'm talking about the United Kingdom, the zone of maximum heating follows this red line as the northern hemisphere is tilted towards the sun at that particular time of the year. In the southern, as we head towards winter in Britain, that's because the northern hemisphere is starting to tilt away from the sun, and therefore the zone of maximum heating is starting to fall in the southern hemisphere, and this line marks the zone of maximum heating. Now, you don't need to explain why it's not straight, why it varies. That's a far more complicated explanation. But as long as you're aware that in our winter time, the sun is directly overhead in the southern hemisphere, and in our summertime, the sun is directly overhead in the northern hemisphere. Now, the actual zone of maximum heating never goes above 30 degrees north of the equator. It's actually what we call the Tropic of Cancer. So on the summer solstice in June the 21st, the sun is directly overhead this point, 30 degrees north. And in the winter solstice on 21st of December, it lies down here. And that's when places like Australia are having their peak point. So let's just clarify. We've talked about low pressure being the zone of maximum heating marks an area of low pressure because of the trade winds meeting at this point. We've mentioned that it lies underneath the thermal equator. This is because this is where the sun is directly overhead, because it's the zone of maximum heating. We then talked about how this causes a huge amount of convection with moisture rising. And we've then talked about how the ITCZ actually moves north and south because of the axis tilt changing throughout the year. Now, that then brings us to the final bit, which is where we want to explain how this explains different amounts of rainfall. So we just go back to this map here. As we move towards our summer, the zone of maximum heating is gradually moving further north till it gets to its peak point right there. Then as we head back to winter, it heads back to the equator. That actually happens in October. And then by the darkest day of the year in December, the zone of maximum heating is down here. So it's continually, the zone of maximum heating is continually migrating back and forward between these points. Now you'll notice the equator is always getting 2 points during the year. So point 1, point 2. Whereas the Tropic of Cancer only gets 1, as does the Tropic of Capricorn, only gets 1 point when it's under the zone of maximum heating, but the equator is always twice. Now, how does that affect rainfall? Well, let's just take, for example, as we move towards our summertime in Scotland, our warmest time. The zone of maximum heating is gradually migrating northwards. So it's passing over the equator, it's heating this area of ocean, huge amounts of evaporation are happening, and therefore there's huge amounts of rainfall on the coast of Africa. As it migrates across the land, the rain is getting less and less, and that's because there's no evaporation happening because this is land and you don't get evaporation over the land. So as those clouds head towards the Tropic of Cancer, there's less and less rainfall. So we would expect it to be very wet where the clouds first meet the land, and as they head inland, there's gradually less rainfall. By the time they get here, there's virtually no rainfall left. As the zone of maximum heating migrates back southwards, it's crossing the land over which it rained, so you're going to get lots of transpiration happening again. And that's the water moisture that fell out of the sky when it originally rained is now going back up again, and then it re-rains a second time as it heads south. And then it's over the equator and it's heading southwards into the southern hemisphere. So when we look back at our final point, when we're trying to explain these points, this is all of the rain, all of the evaporation happening as the zone of maximum heating heads towards the northern hemisphere. So huge amounts of evaporation of the Atlantic Ocean. And by the time we hit our hottest time of the year, there's huge amounts of rain over Abidjan. Then as the clouds move northwards towards Ouagadougou, there's more rainfall later on, a couple of months later, and Nioro. And there's a little bit less in Abidjan because the zone of maximum heating has migrated north of this point. But as it comes back again, it brings more rainfall, second time of the year, which is what we can see here. Whereas Ouagadougou and Nioro then lie too far north of that. Now, there are some other final little points you can bring in. Why is Nioro so dry? And it's not just to do with the fact that there's only 1 point of the year when it lies under the zone of maximum heating. Most of the year, Nioro, if I go back to this little graphic here, is well beyond the zone of maximum heating, because Nioro lies up here. And that means it's lying under the tropical continental air mass for most of the year. Now, the tropical continental air mass isn't just very dry, it also brings very, very dry, strong northeast trade winds called the Harmattan. Now, the Harmattan winds, as they blow across the African desert, the Sahara Desert, they dry out the land, and they cause huge amounts of any moisture left is dried out by these hot, dry winds, which creates lots of evaporation. And that also explains why this area of Nioro receives so little rain. It's the drying winds from the continental air mass. We can see that in this diagram here, tropical continental air mass. So the winds are coming across the land, drying out the land, and that explains why there's no rain at all for 6 months of the year. So that's an additional point you can bring into your answer. I do have a model answer to this, which you can have a little look at if you want.